thing here, then here is our what? Opposite. So if here is our opposite, here will be our what? Adjacent. But if here is our opposite, here is our what? Adjacent. The two of them can interchange, but the hypotenuse can never what? Interchange. It still remains the hypotenuse. It doesn't need all these this. Good afternoon, class. Today we are going to be treating on a very interesting and important topic, which is trigonometry. Under trigonometry, there are subtopics under trigonometry whereby we are having our Pythagoras theorem. We are also having the relationship between the trig ratios. We also have the special angles. The special angles whereby even an engineering student and a medical student needs it. Then we also have the trig identity. We call it the complementary angles. We also have the quadrant of a circle, which help us as a student to know when an angle should have a positive and a negative sign. It is the quadrant that will determine if this angle is having a positive sign or is having a negative sign. And also have the sine and cosine, whereby we are having that a all over small a all over sine capital A is equal to what? B capital and sine capital C. So this is for sine. But cosine we are having that what? For example, if I'm having that b squared is equal to what? Q squared plus what? R squared minus what? 2 what? Q R plus what? Theta. That is for what? Cosine rule and the what? Rest. So we are going to start with what? Pythagoras theorem. Now, what do we understand by that word? Trigonometry. Whenever we are talking about what is it trying to tell us?
Three.
Yeah?
Three.
We are talking about what? A three-sided shape. A three-sided shape. Whenever we are talking about trigonometry, there is a triangle that we always use in solving what? Trigonometric problems. Yeah. And what's the name of the triangle? It is the what? The right angled triangle. The man Pythagoras, with the help of the right angled triangle, now invented that he said that the longest side is the what? Hypotenuse. Then the other two sides can decide to what? Interchange at any time. What does it mean by that? If the theta or the angle is here, that means here will be our what? Opposite. But if the angle or the theta is written here, then here is our what? Opposite. So if here is our opposite, here will be our what? Adjacent. But if here is our opposite, here is our what? Adjacent. The two of them can interchange, but the hypotenuse can never what? Interchange. It still remains the hypotenuse. It doesn't need all these this polygamy family. He doesn't need it. He said that I want to be on my what? Own. So we can name here to be our what? Opposite. And here to be our what? Adjacent. During that time, the man Pythagoras was now saying that he wants to prove a name for himself. Now, he was like, I want to bring out a formula that even when I'm gone, that they will still be using it up to what? Now. Just like Isaac Newton, just like Faraday's law of electrolysis and the what? Rest. Now, he said that this longest side, that if this longest side is equal to what? The sum of what? These two what? Sides. The man Pythagoras started with what? C squared is equal to A it started with C is equal to what? A plus what?
B
B. Now he was experimenting something to now prove what he was saying. He said that let's assume here to be 5, here to be what? 3, and here to be what? 4. He now said now the longest side is equal to what? These two. You know, we now came and have what? 5 is equal to what? 3 plus what? 4. I'm now having that 5 is equal to what? 7. Is the equation balanced? No. Afterward, using that, he saw that the equation was not what? Balanced. He was now saying, what else can I do to what? Make sure that this law that I'm about to prove will be what? Standard. That it can pass that hypotenuse, it can pass that theory, it can pass that observation and everything, and it is made what? A theory. So now, he now said that let me add what? Square. He said that after adding square, if it doesn't go, I'll still what? Go ahead. Just like Faraday's, the man will have to what? Try 900 and what? 99 times. Chineke, can you do that? Just ordinary electricity. He did it the first time, he failed. He did it the second time, he failed. The third, the 10th. Nah. If they ask you to do it, the moment you reach that 10, you won't even reach 10, you will say that this is not my what? Calling. That is not my but he tried it what? 999 times. In the 1000 attempts. That is how we got how to produce what? Electric what? Bulb. So let me add square. If it doesn't go, I'll still continue. You now have to add that word square. And you know that anything you do on the right hand side, you must do it at the what? Left hand side. Now we are now having that word 5 was squared is equal to 3 squared plus what? 4 squared. We are having that 5 squared is equal to what? 25. I'm having to be what? 9 plus 16. 25 is equal to what? 25. So after solving this, he saw that what? That this square, that by squaring all of them, it will give us, it will prove to that what he's trying to what? Show to the world is correct. He now have to what? Go to the world, people that knows more than him, and say, now I've gotten what I was trying to tell you. This is how it is being done. That was how what? The Pythagoras formula what came to what? Existence. Now, as he was after proving it, he now said that there are many criteria that needs to be solved. That's when he introduced what we call the word the whereby that we have that word that sine theta is equal to what? Opposite over what? Hypotenuse. We have that cos theta is equal to what? Adjacent all over hypotenuse. And we have our tan theta to be what? Opposite over adjacent. These are the 3 initial variables the man Pythagoras introduced. But as time goes on, he saw that this Socrates cannot solve every what? Question. He started thinking, what else can I do? What else can be done to make sure that these questions the students meet the end needs? He now introduced what we call the what? The second, the cosecant, cotangent, and what? Cotangent. When he was thinking it, he made it easier for students to know the word secret in finding the word, the sec, cosec, and the word cotangent. He said that remove the first 2 letters. By removing the first 2 letters of each one, that the 3rd letter will determine what you are going to use to solve the word question. Now, removing these first 2 letters, what are we going to have here? C. Now, C represents what? Cos. He said that second is equal to what? The inverse of what? Cos theta. Removing these first 2 letters, what are we having here? So I'm now having it to be what? 1 over what? Sine what? Theta. And removing these first two letters, what are we having as the next?
1 over tan.
Tan. Which now we're having what? 1 over what?
Tan theta.
Tan what? Theta.
Tan theta.
Now in other words, we're having our second to be what? Hypotenuse over what? Adjacent. And we're having this to be what? Hypotenuse over what? Opposite. And what? This one to be what?
Opposite.
Adjacent over what? Opposite.
Sorry. Gini kan dirimu.
Are you there? Are you there?
second. Nice one.
It's a secret when it comes to trigonometry. What are the secrets? Now, what are the secrets there? Well, the secret is that if I'm having 5 here, having 3 here, here will be what? 4. If I'm having 13 here, having 5 here, here will be what? 12. If I'm having 17 here, having 8 here, here is what? 15. These are what? 3 major constant numbers that is always used in what? JAMB. These are the 3 major constant numbers that is always used for JAMB bites. The moment the longest side is having 5, this side is having 4 or 3. If here is 4, that means here will be what? 3. But if here is 3, here is what? 4. Why did I say so? We have seen how we got this. Then coming here, if the longest side is 13, and here is either here is 12 or 5. If here is 5, here is going to be what? 12. But it says 12, here is going to be what? 5. 13 squared is equal to what? 13 squared is equal to what? 13 squared is equal to what? 16 what? 9. We'll keep it one side. 5 squared is equal to what?
25.
12 squared is equal to what?
144.
144 plus 25 is equal to what? 160 what? 9. Now, if I'm having the longest side to be 17, the opposite side can be 8 or what? 12. It's normal that it's going to be 8 here. If it is 12 that they gave you as the opposite side, write your 12 in your opposite side and put 8 in the what? Adjacent side. So in other words, if I'm having 17 squared, it will give us what? 2 8 what? 9. 8 squared is equal to what?
64.
15 squared is equal to what? 225. 225 plus what? 64 is equal to what? 289. These are the 3 major constant numbers that is always used. It is always repeated. It always will occur because they know that them giving you a complex number might what? Take much of your what? Time. So they will give you mainly these 3 constant what? Numbers to what? Solve some what? Question. Now when it comes to the relationship between 3 ratios, they are trying to tell us that these are the things that is being done. These are the things, how things have been done. They are trying to tell us that they have worked on it. Now they are trying to prove it to us that if sine theta divided by cos theta, that it will give us what? Tan what? Theta. What is sine theta? Opposite over what?
Hypotenuse.
What is cos theta? Adjacent over what?
Hypotenuse.
That if the 2 of them divide, it will give us what? Tan theta, which is what? Opposite over what? Adjacent. Now we are going to use a real number, and we are also going to use what? Alphabets. Now using a real number, if I say that what? Sine theta, what sine theta? Opposite over what? Opposite over what?
Hypotenuse.
Opposite over hypotenuse. So we can use any of these 3 numbers. Using any of these 3 numbers, I can say let me use 17. This one. I will now say which is what? 8 over what? 17. Divided by what is our cos theta? Which is what? We are making use of this. 15 over what? Now what is our tan theta here? What is our tan theta? Our tan theta is equal to what? Which is what? 8 over what? 15. They are trying to tell you that after solving, you are going to have what? 8 over what? 15. Now I will now say that what 8 over 17. What will happen? Times. And the moment times comes in, what happens? 17 over what? 15. Can anything cancel out? 17 will cancel 17. I'm having what? 8 over what? 15. So what they are trying to tell us is that if we use cos to divide sin theta, it will give us what? Tan what? Theta. We have seen why they say so. Now using an alphabet, I have that what? Sin theta is what? A over what? C divided by what? B over C. I'm now having that A over C times what? C over what? B. If I divide, I'm having it to be what? A over what? B. And my tan theta is what? A over what? B. With that, solve, prove that second what? Question. Prove the second one question, which is what? Cos theta divided by what? Sin what? Theta. Cos theta divided by what? Sin what? Theta.
And the cost of cotangent.
Nah.
Cotangent now.
You can substitute it and what? Put what? C what? Squared. With that, we can now say that what? C squared all over what? C squared. If we divide it, we are having what? 1. Have you seen the reason why they say that after what? Simplifying sin squared theta plus cos squared theta, we are going to have what? 1.
1.
If we decide to use a real number, sin theta is what? 8 over what? 17 all squared plus what? 15 over what? 17 all squared. I'm now having that was 64 over what? 289 plus what? 225 all over what? 289. They have the same denominator. I'll add the what? The two numerator. This plus this is equal to what? 289. I will now pick one of the denominator. Now I'm not having what? 289. If two of them divide, I'm having 1. As we have seen the what? Relationship between the trig ratios, let's go to the what? Special
angles.
What are the special angles?
Sine 45.
Here are the special angles. Our special angles to be what? 0 degrees, 30 degrees,
45 degrees, and
60 degrees, and what?
90
degrees. These are the what? Special
angles.
These are the what? Special angles. Now, since we are having this, there are two major constant angles that we always have here, which is what? 0 and what? 90 degrees. Why did I say that always constant? When we come to 0 degrees, we have that sine 0 is equal to 0. We have that cos 0 is equal to what? 1. And we have that tan 0 is equal to what? 0. Then when it comes to 90 degrees, we have that sine 90 is equal to what?
1.
Cos 90 is equal to
0.
And tan 90 is equal to what? Infinity. Why is it infinity? Because the numbers are too much. The numbers are what? Too much. So the calculator or this thing cannot contain it. That's why sometimes you see what? Mass error. it can't contain the number. The numbers are too complex for the computer. So, or the calculator, it should tell you that what? Mass what? Error. Now, to get 45 degrees, a Pythagoras what? Or a right angled triangle is used, but to get 30 degrees and what? 60 degrees and equilateral triangle is used. Finding the longest side, what are we going to add there? We now say that what? C squared is equal to A squared plus B squared. C squared is equal to 1 plus 1 squared 1 squared. C squared is equal to what? 1 plus 1. C squared is equal to what? 2. C is equal to what? Square root of what? 2, which is what? So what? 2. Now means here is what? So what? 2. We now say let's find out what? Which angle are we looking for? 45 degrees. We now say that sine 45 is equal to, now remember that since it's 45, here will be 45, 3 of us, and here will also be what? 45. Now that means anywhere can be my opposite and anywhere can be my what? Adjacent. Because if here is my opposite, it's still the same thing because two of them are sharing the same what? Equal angle. Here is 45, here is 45. So I can name anywhere my opposite and I can name anywhere my what? Adjacent. So I'll now say that what? Opposite over what? Adjacent over hypotenuse, which is sine theta. I'll now say that is what? 1 over what? So 2. Is this our final answer?
Yeah.
No. The law of governing mathematics said that what? If you have what? Square root as the denominator, try everything possible to eliminate that what? Square root. If the square root is the numerator, no problem. But as far as it's the denominator, do everything possible to eliminate it. And how do we eliminate this word? Square root.
Times 2
what do we call it?
Third.
What do we call it? What do we call it? Rationalization. You have to what? Rationalize. Rationalizing, I'll now say that what? 1 over sod 2 times what? Sod 2 all over what? Sod what? 2. 1 times sod 2 is what?
Sod 2.
Sod 2 times sod 2 is what? Sod what? 4. Now I'm now having that what? Sod 2 all over square root of 4 is what? 2. That means that sine 45 is equal to 1 over root 2 or what? Root 2 over what? 2. I'm having that cos 45 is equal to, now since I'm having cos 45, any of them can be my what? Opposite and adjacent. So adjacent over what? Hypotenuse, which is what? 1 over what? Root what? 2, which is equal to what? So 2 over what? 2. Now I'm now having that what? Tan what? Is equal to opposite over what? Adjacent, which is what? 1 over what? 1, which is equal to 1. That is why in your calculator, if you press your what? Tan 45 degrees, it will give you what? 1. Now, to get our what? Angle 30 degrees and what? Angle 60 degrees, an equilateral triangle is what? Used. How do we make use of the equilateral triangle? Where all the sides are equal and all the angles are what? Equal. We are now having that what? 60, 60, 60, and all the sides is what? 2, 2. Now, but they say that we should make use of an equilateral triangle to get what? Angle 30 and what? 60. But what are we having here? Only angle what? 60. So what are we going to do? We divide the triangle into 2. Dividing the triangle into 2, what will be here? And what will be here? What will be here? What will be there? 1, 1. Because from here to here is what? 2. That means since it is being divided into 2, here is 1 and here is what? 1. So what's the next thing? We bring one part of the triangle out. Bringing it out, I'm now having something like this. Here is what? 60 degrees. Here is what? 30 degrees. Here is what? Here is what? Do we know here? Find here. Angle. Now let's look for what? Angle what? 30 degrees. Now, which angle are we looking for? 30. So where is our opposite? Where is our opposite?
1.
Here.
1.
Yes. We are looking for angle 30 degrees. So here is our opposite. And here is our what? Adjacent. The place facing the angle is the what? Opposite. Then the other side is the what? Adjacent. So we now say that what? That sine 30 degrees is equal to opposite over what? Hypotenuse. Which is equal to what? 1 over 2. I'm now having that what? Cos what? 30 is equal to what? Adjacent over what? Hypotenuse, which is what?
So
3 all over what? 2. And we have that what? Tan what?
30.
Which is equal to what? Opposite over what? Adjacent, which is 1 over what? So what? 3. Which is equal to so 3 all over what? 3. So 3 all over what? 3. We now say let's find for 60 degrees. Now we are looking for 60 degrees. Where will be our opposite now? So 3. And here will be our what? Adjacent. I'm now saying that what? That sine 60 is equal to what?
So 3 all over 2.
Cos what? 60 is equal to what? 1 over what? 2. And what? Tan what? 60 is equal to what? So 3 all over what? 1. And any number you divide by 1 is something like that number, which is what? So what? 3. This is how both the 45, the 60, and the what? 2 plus 1 times 3 is what? So what? 3 all over 2 times 2,
4.
2 times 3
Minus
plus what? 2 sod what? 3. So 3 times 2 is what? Minus what? Minus what? 2 sod what? 3. And so 3 times so 3 is what?
minus of 9.
Minus sod what? 9. We are now having that what? 2 plus so 3 all over 4. This and this will cancel out. What is square root of 9?
3.
Is it what? Minus what?
3.
I'm now having that what? 2 plus so what? 3 all over what?
1.
And it's equal to what?
2 plus 3.
3. What? 1 minus tan what? Squared A. What is the value of A? 30. So I'm now say that what? 2. What is the value of 30? What is the special angle of 30?
So 3 over 3.
So 3 all over what? 3. All over 1 minus so 3 all over what? 3 all squared. We are now having that what? 2 times this is what? 2 so what? 3 all over what? 3 divided by opening this bracket. What are we going to have? 1 minus what?
C all over 9.
1 minus what? 3 all over what? 9. How is that so? I'm now having so 3 all squared all over what? 3 all squared. Square Square will cancel what? Square root. I'm now having what? 3. 3 squared is what? 9. Which is the same thing as what? 1 over what? 3. So I'm now having it to be 2 so 3 all over 3 divided by 1 minus what? 1 over 3. Now let's simplify this first. Simplifying it, we are now having that what? 1 over 1 minus what? 1 over 3. What is the LCM?
3.
3 divided by 1
3.
times this minus 3 divided times this 1. I'm now having what? 2 over what? 3. That means I'm now having what? 2 sub what? 3 all over 3 divided by 2 over 3. 2 sub 3 all over 3 times what? 3 over what? 2. 3 cancels what? 3. 2 divide itself. Divide. So what's our answer? So what? 3. After writing this, you try that third one. 3 all over 4. So that 0 degrees is less than theta is less than
180 degrees. Find cos theta.
Cos what?
Theta plus sine theta.
So, how do we start solving this question? First of all, we have to represent this in what? A diagram. We have to represent it in what? A diagram. Representing it in a diagram, we are now having that what? What is tan?
Opposite over adjacent.
So it is what? Minus
Minus
3 all
3,
over what?
4.
4. We have to find here. Finding here is what? 5. How is that so? C squared is equal to what? A squared plus what? B squared. I'm now having that what? C squared is equal to minus 3 all squared plus what? 4 squared. Minus 3 times minus 3. Minus cancels minus. I'm having what? 9. So C squared is equal to what? 9 plus 16.
Which is
C squared is equal to 25. C is equal to square root of what? 25. So C is equal to 5. Now, since we have gotten that, that means since tan theta is equal to minus 3 over 4, I'll now say that sine theta, which is opposite over what? Hypotenuse is minus 3 over what? 5. And cos theta is equal to what? 4 over 5. With that, I'll now say that what? Cos theta plus sine what? Theta. What is the value of cos theta? 4 over what? 5 plus bracket what? Minus 3 over what? 5. Plus times minus is what? Minus. So 4 over 5 minus what? 3 over what? 5. They have the same word denominator. So 4 minus 3 is what?
1 over 5.
1 over what? So 3 plus what? So 3 over what? 3. Which will lead us to 1 plus. So 3 times so 3 is what?
So 9.
Which is what? 3 of where? So 3 all over 3. All over. What is the LCM of these two?
1. 3. So
I will now say that what? The LCM is 3. 3 divided by 1 is what?
3.
3 times or 3 is what? 3 sod what? 3. Then 3 divide 3. 1 times or 3 is what? Plus what? Sod what? 3. This divide, what am I going to have?
1.
1. 1 plus what? 1. Divided by this plus this is what? 4 sod what? 3 all over 3. I'm now having that what? 2 over 1 divided by what? 4 sod what? 3 all over 3. What is the next thing? We're having our what? 2 over what? 1 times what? 3 all over what? 4 sub 3. 2 divide.
1,
Divide.
2,
So I'm now having what? 3 all over what? 2 sub what? 3.
rationalize.
Rationalizing, we're having what? 2 sub what? 3 all over what? 2 sub what? 3. This time this is what?
6
6 sub what? 3 all over. This time this is what? 4 sub what? 9. 6 sub 3 all over 4 times what?
3,
3.
making it 12.
Now we are now having what?
6 or 3,
6 or 3 all over what? 12. 6 divide itself. 1. Area. Divide. So we are having our answer to be what?
3 all over
So 3 all over what? 2.
Number.
Assignment.